Hey everyone, and welcome to today's Explainer. I am honestly incredibly excited about this one because we are finally pulling back the curtain on the Junos operating system. If you've ever wanted a clear, plain English breakdown of how Junos logic actually operates under the hood, you are in exactly the right place. We're going to demystify the Junos Policy Framework today, and we'll be focusing heavily on routing policies and firewall filters. So let's just dive right into it. Think about a massive core router for just a second. It is literally getting bombarded with millions of packets and countless route updates every single second. So how does a Junos device instantly and accurately decide which packets to drop into the abyss and which network routes to proudly advertise to its neighbors? Well, it all comes down to a hidden, highly structured decision-making process.
Here is our game plan for today. 1. The Junos Policy Framework. 2. Anatomy of a policy. 3. Routing policies explained. 4. Firewall filter concepts. 5. Match conditions and actions. And finally, 6. Configuring and monitoring.
All right, kicking things off with Section 1, the Junos Policy Framework, the two gatekeepers.
Okay, here is the absolute foundational concept you really need to grasp before we go any further. The Junos Policy Framework is broadly split into two distinct jobs. On one side, we've got routing policies. You can think of these as the traffic cops. They manage the flow of routing information. They basically dictate which routes are placed into the routing tables and what information is shared with other routers. In short, they build the map. Now on the other side, we have firewall filters. These are your bouncers. They do not care about building the map. They evaluate the actual transiting data packets themselves. They're checking the IDs of the packets hitting your physical interfaces to see if they're allowed in or if they need to be tossed out.
Moving right along to Section 2, Anatomy of a Policy, the shared structural DNA.
So even though they do different jobs, everything in the Junos policy architecture boils down to what we call a term. A term is simply a named structure within a policy where you define specific conditions to look for and the resulting actions to take if those conditions are met. It is basically the fundamental building block of logic in this ecosystem. Inside each of these terms, we have a super simple two-part structure, a from statement and a then statement. The from statement contains your match conditions. Basically, what are we looking for? Now, here is the absolutely crucial point. If you put multiple conditions inside a from statement, Junos evaluates them using a logical and. That means a route or a packet has to meet every single condition you list in order for it to be considered a match. If it does match, we move to the then statement, which just executes the action you've defined, like accepting or dropping that traffic.
And this brings us to how the router actually thinks in real time. The processing is strictly chronological, from top to bottom. In step 1, the incoming packet or route is evaluated against term 1. But hey, if it doesn't match all the conditions, the router doesn't just give up. Step 2 acts as a logical OR, seamlessly shifting the evaluation down to term 2 and so on. Finally, in step 3, if the packet or route runs through every single term and matches absolutely nothing, well, it hits a default action. We're going to talk about what that default is in just a bit, because it's a big deal.
All right, Section 3, Routing Policies Explained, Directing the Map.
Now remember, routing protocols have two main jobs. They learn routes and they advertise routes. To control this, Junos uses two directional concepts, import and export. An import policy acts on routing information before it gets placed into your device's routing table. It's essentially how you filter what you're willing to learn from the outside world. An export policy does the exact opposite. It controls which active routes from your routing table are pulled out and actively advertised to your neighbor routers via protocols like BGP or OSPF.
But it gets cooler. An action in a routing policy isn't just a simple yes or no. Your actions can actually be incredibly dynamic. You can actively manipulate the characteristics of a route on the fly. You can set a tag value, like for OSPF or IISIS routes. You can change local preferences, or even alter the route validation state. You aren't just reading the map, you are actively painting the network map to your exact specifications.
Section 4, Firewall Filter Concepts, the Stateless Bouncer.
Okay, if you take away one thing from this explainer, it should be the word stateless. Junos firewall filters are stateless access control lists. This means they do not track the state of network connections. They don't know, and they don't care if a packet is part of an ongoing TCP handshake or a brand new request. They simply look at a packet statically, checking the source IP, destination IP, protocol, and ports, and make an immediate decision right then and there.
This, by the way, is exactly why we often pair these stateless filters with unicast reverse path forwarding, or URPF. Since the filter is stateless, URPF steps in to strictly verify that the source IP addresses on these packets are actually valid and reachable.
You'll typically apply these filters in one of two ways. First, directly on physical interfaces, acting as ingress or egress filters for transiting data. Standard stuff. But the second application is a massive pro tip for network protection, applying a filter directly to the loopback interface, or low zero. Because all traffic destined for the router itself goes directly to the routing engine, applying a filter on low zero acts as an umbrella. It protects the router's brain from denial of service attacks, like ICMP floods, without you having to go in and configure filters on every single physical port. Pretty neat, right?
Section 5. Match conditions and actions. Enforcing the rules.
So when a packet actually matches your conditions, you typically choose one of 3 terminating actions. Accept is pretty obvious. It lets the packet through. But look closely at the difference between the next 2. Discard means the packet is dropped silently. The sender has absolutely no idea what happened. The packet just vanished into a black hole. Reject, on the other hand, drops the packet but politely sends an ICMP destination unreachable message back to the sender. From a security standpoint, discard is usually your preferred option, simply so you don't give potential attackers any clues about what your firewall rules look like.
This brings us to a really critical knowledge check. Let's say you've set up a super complex list of terms for your firewall filter. A packet comes in, flows down from top to bottom, and it matches absolutely none of your configured terms. What happens next?
The answer is the implicit rule. The default action in Junos is a silent discard. If you do not explicitly tell Junos what to do with unclassified traffic, it drops it. It acts as an implicit deny all at the very end of your filter. Now, this is a crucial safety mechanism, for sure. But if you don't know it's there, you might accidentally drop perfectly legitimate traffic just because you forgot to write an accept term for it.
Finally, Section 6, Configuring and Monitoring. Let's see this in the CLI.
This right here is exactly why Junos is so popular among network engineers. The CLI perfectly mirrors the logical anatomy we were discussing earlier. You can see the visual hierarchy. You have your policy options, which houses your policy statement. Inside that, you define your term. And, nested elegantly right inside the term, are the from conditions and the then actions. It is readable, it's block structured, and it's perfectly organized.
And when you want to verify what's actively running on the box, you simply use the command show policy options. This spits out the exact structure we just talked about. It makes it incredibly easy to read through your terms sequentially and audit exactly what your policy is doing, right down to the specific subroutines.
Configuring the bouncer, your firewall filters, is just as straightforward. Under the firewall family hierarchy, you can set a term that looks for protocol TCP or UDP and specify exact source addresses. You are literally spelling out the match conditions in plain logical commands. It just makes sense.
However, you do need to take note of this constraint. If you find yourself working on specific hardware, like the OCX series switches, for example, there are some syntax exceptions. On these specific platforms, individual conditions cannot contain value lists or ranges, and you actually cannot negate conditions using the except keyword. So always check the specific hardware documentation. The foundational logic we covered today remains exactly the same, but the exact syntax constraints can vary just a little bit based on the underlying silicon.
And that brings us to the end of our breakdown. We've covered the structure, the gatekeepers, and the underlying logic of the Junos Policy Framework. But I really want to leave you with this final, somewhat provocative thought. Because Junos relies so heavily on that chronological evaluation and those default end actions we talked about, a single misconfigured default can literally drop your entire routing table or silently lock you out of your own device. So I challenge you, log into your systems today and ask yourself, are your default policies working for you or against you? Thanks so much for joining me on this explainer. And as always, keep learning.